What's up, guys? Welcome back to another AMC video. We're going to be solving problem number 25 from the 2022 exam. So let's get started. A cricket randomly hops between four leaves. Four leaves. On each turn, hopping to one of the other three leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? Okay, so this problem seems simple enough, right? It's just asking how is the cricket, or what is the probability that the cricket, we're going to call this guy Larry, right? What's the probability that Larry, after making 4 hops, returns to this original leaf? And we're going to call this A just for naming purposes. So A. And we'll call all the other ones B. Now, you may be asking, why are we all giving them the same name? Shouldn't we give this one B and then this one C and then this one D? Well, the answer is we can, but we don't have to. See, the way we're going to solve this problem is by doing casework. So we're going to see what are the cases in which Larry can come back to A after 4 hops and what is the probability of that. And by labeling all of these B, we can make our life easier so we have less cases. But why does this work? Well, it's because all these have equal probability of happening, right? In the question it states equal probability. So it doesn't matter if we label all of these B, right? Okay, so now let's get to the solving part. So we're just going to brainstorm cases, right? That's what casework is. Well, one of the most obvious cases is where Larry goes to all the B leaves, B, 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 before he comes back to A. So we can denote this case as B, 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 A, right? He comes back to A. Okay, that's one case. And the key thing to realize at this point of the question is that Larry cannot hop to just 2 B leaves. Why? Well, let's say he hops to this B leaf and this B leaf. Now, we only said 2 B leaves, so he has to come back to A. But if he comes back to A, then, oops, why did that happen? But if he comes back to A, then he'll have to go to a B for his last move, and that's not going to work, since we don't want that. So it has to be either 1 B leaf or 3 B leaves. So yeah, that brings us to our next case, 1 B leaf. So he can hop, so from A to B, back to A, and then back to B, and back to A. But you may be asking me, well, okay, isn't the case you just showed me different from, let's say he hops this B leaf back to A, but then he hops this B leaf and back to A? Well, the answer is no, because remember, it's equal probability. It doesn't matter which B leaf he hops to, right? So we can just denote all of this as one case. Let's do this in green. A, oh, a bit to the side. A, oh no, not A. B, A, B, A, right? He hops to one of the B leaves, and then he goes back to the A leaf, and then he hops to one of the B leaf and goes back to A leaf. That works. So yeah, that's just going to be our last case. So now let's evaluate these cases. Okay, so first of all, what's the probability of getting to a B leaf? Well, probability of B leaf is just going to be 2/3. Or, well, in the first move, it's going to be 1. But any time after that, it's always going to be 2/3. Because let's say the cricket is already on a B leaf. It has 2 B leaves and 1 A leaf. So it has 2/3 chance of going to a B leaf. Okay, now let's go back here. So, what is the probability it has to go to an A leaf? Well, Larry has to go to a B leaf first, right? Yeah, he has to go to a B leaf first because he's already on an A leaf. And then B leaf again, that's going to be 2/3, right? Let's say he goes to this one. He can either go to this one or this one. 2/3. And then same 2/3 again, right? It's the same thing over. And then going to A, let's say he ends up on the last B leaf here. On this leaf, then so 1/3 chance of going to A. So 1/3. Okay, then next case, B, A, B, A. So he goes to a B leaf first. Well, 1, right? He can't go to an A leaf again since he's already on an A leaf. And then going back to an A leaf is going to be from this B leaf, let's say, it's going to be 1/3. Right? And then he has to go to a B leaf again, right? He only has 3 options, which are all B leaves. And then it's just going to be a 1/3 probability to come back to A once again. So it's kind of like a loop. Okay, so now let's evaluate these. We can disregard the 1 here pretty much, right? So that doesn't matter. Let's just erase that. So 2/3 times 2/3 times 1/3, that's going to be 2 times 2 times 1, so 4 over 3 cubed, which is 27. Next, we're going to do this one. So this is just going to be, we can cross out the ones. Just 1/3 times 1/3, which is 1/9. And now we just need to add these, right? We just need to add the number of cases to get the total number of cases that work. And this is the same thing as, let's do this in a nice orange. It's the same thing as 4 over 27 plus 3 over 27, which is the same thing as 7 over 27. And that's the most simplified, so this is just going to be our answer. So, just like that, we got answer choice E as our final solution. So this problem was all about realizing that we can label these 3 leaves as just B, right? And this is the concept of simplifying casework. So then we just get 2 fairly simple cases, right? And from there, it's pretty simple. We just need to add the probabilities to get the total probability. So I'll be back with more videos like these ones. So smash that subscribe button, and I'll see you guys in the next one.